I would like to talk about the charging and discharging of capacitors, tiny devices that can store electrical energy. I'm going to provide a comprehensive overview of capacitors. Considering their structure, how they store and release electrical charge, the different types of capacitors, the concept of capacitance and voltage, and some key real-life applications of capacitors. To begin with, what is a capacitor? A capacitor is a tiny device that can store electrical energy and release it when needed. While batteries store energy in a chemical substance, capacitors store energy in an electric field. Capacitors are mainly used to regulate voltage, smooth power fluctuations, and store energy for later use. Let's consider the structure of a capacitor. It's made up of two conductive plates, usually made of metal. These plates never touch each other. Between these plates there's a layer of non-conductive material, such as air, plastic, or ceramic. This is called dielectric, and it increases energy storage capacity. Plus, there are the leads, that is the wire that connect the capacitor to the circuit. A capacitor's ability to store electric charge is called capacitance and is measured in farads. The shape, size, and kind of material of the plates and dielectric are all factors that affect capacitance. But how does a capacitor charge? Simply put, it's a four-step process. First, we connect the capacitor to a power source, such as a battery. Electric charge starts to flow into the capacitor. Second, electrons start to pile up on one plate, creating a negative charge. As a consequence, the other plate is positively charged. This creates an electric field between the plates, precisely in the dielectric. The dielectric stores electric charge until the voltage across the plates corresponds to the voltage provided by the battery. At this point, the capacitor reaches full capacity and stops charging. And now it's time to look at how a capacitor discharges. First, we disconnect the capacitor from the power source. The electric field collapses, so the stored charge flows back into the circuit. This means that the electrons move back the negative place to the positive. This flow of electrons powers the circuit for a certain time. However, the capacitor discharges quickly, compared to the time needed to charge. The time needed to discharge also depends on the type of capacitor. Let's see the most common types. First, we have ceramic capacitors. They are small and cheap. They have low capacitance, but can handle high voltages. They are often used in high-frequency circuits. Second, there are electrolytic capacitors. They can store larger quantities of energy. So they are commonly used in power supply circuits. Third, there are film capacitors. They store charge in a dielectric made of a plastic film. They are stable and reliable, and are commonly used in audio equipment and motor circuits. Unlike electrolytic capacitors, film capacitors are not polarized. How much charge can a capacitor store? This depends on two things, capacitance and voltage. The higher the capacitance, the more energy a capacitor can store. Capacitance is often measured in microfarads, correspondent to the millionth part of a farad. Capacitors, on the other hand, are rated for a maximum voltage. If you exceed this voltage, the dielectric may break down. Now let's consider the main real-life applications of capacitors. First, we have power factor correction. Capacitors can improve energy efficiency by balancing power supply and demand. As a consequence, they are used in industrial machinery to reduce waste and lower electricity bills. Then, capacitors are used in energy storage devices, as they can store charge and release it quickly. For this reason, they are used in systems that need short bursts of power, such as camera flashes or electric vehicles. Plus, capacitors are used in signal coupling, to separate AC signals from DC signals in communication circuits. In this case, they are commonly used in radios and audio devices. Lastly, capacitors are used as timing devices in electronic circuits. They can be present in clocks and LED blinking patterns. To sum things up, capacitors are essential components in electronics, and are used in a wide range of applications ranging from storing energy, to regulating voltage, to managing signals. Understanding how capacitors work allows us to appreciate their crucial role in modern technology. Thank you for your attention. If you liked this video, don't forget to subscribe to the channel and activate the bell to be notified when new content is available. See you soon.